All right, so we're going to go ahead and move on to 1.3, which is representing and describing transformations. Couple of definitions here. For transformations is a function that changes the position, shape, or size of a figure. So a transformation is literally going to be all the things we're doing today. It could be a reflection, it could be a dilation where, something expands and gets larger. It could be rotating something. There's lots of different transformations that you can do to images. A pre-image is the figure used as an input of a transformation. So a pre-image would be like your original. Let's say this is your original triangle, ABC, and it's going to undergo a transformation. So they'll give you some type of a rule that you'll see in the next example. Like, let's say every x is going to be subtracted by 2. So the new one, let's say your whole figure would go down. And instead, your new shape would be what's identified as, they call this a prime here. It's like a little quotation or symbol. Okay. So this is your pre-image, ABC, and your image is going to be what you get after you've done the transformation. Okay. Congruence, all angles and sides have to be exactly the same length, and they have to be the exact same measurement for the angles. So in order for two shapes to be congruent, they could be turned a little bit. Like, let's say this is the exact same triangle, and then maybe we see it this way. It's flipped or rotated, but the angle measures are still exactly the same and the side lengths are exactly the same. So these two triangles would be considered congruent. It's the same shape and size, but they could be flipped or translated. Now, when it comes to your guys' definitions, please don't worry. You'll notice that my definitions are quite different from the book. And that's because I really just want you to understand what the vocabulary is. I never expect for you guys to be able to dictate a book definition. Okay, so if you can either show me or the basics of it, I'll be using the same type of vocabulary if you ever are quizzed on anything when it comes to vocab. All right, here we go. Let's look at an example. Find the unknown coordinates for each transformation and draw the image. So what I'm going to do here is I'm actually going to go ahead, and I find that students do better with these types of problems when we solve it algebraically because we're more comfortable with algebra. So I'm going to start by looking at each letter individually. So let's look at letter A, for example, and I'm going to find the point of letter A. My x is 0, and my y is going to be 1, 2, 3, 4, it looks like. Okay. I am going to, this is my pre-image, A is 0, 4. I'm going to find the new image given this rule. So that's going to be my A prime point. And all I'm going to do is plug it in. So for the first x value, my new x value, I have the equation x minus 4. So if I plug in, I have 0 minus 4. For my new y value, I have y minus 3. So my y is 4, 4 minus 3. And I'm just going to go ahead and complete that. 0 minus 4 is negative 4, and 4 minus 3 is 1. And I'm going to plot this point on my new axes here. Let's see. So x is negative 4, 1, 2, 3, 4, and my y is a positive 1. Make sure when you're doing these that you label them. Okay, labeling it not necessarily with the point, but labeling it as, A prime or whatever. Okay, for the next one, let me do the next color here. Let's look at B. B is the point. My x this time is 3 and my y is 0. I have to use the same rule. So my new B prime is going to plug into here. So 3 minus 4, and my y is 0 minus 3. And then I'm just going to go ahead and simplify that. 3 minus 4 is -1, and 0 minus 3 is -3. Now, if you find yourself wanting to plug into your calculator when you're doing these calculations here, I need you guys to stop, okay? One of the things or disadvantages I've seen from students last year in my geometry class and last year in my Algebra 2 class, I saw that they just were really bad at their basic math, and they grew so much in my class because I really forced them not to be reliant on their calculator. One of my goals, you guys are looking at SATs and AP exams, and one of the strategies for taking those tests is to actually use your calculator the least amount as possible. The reason for that being is because you're going to run out of time. So when it comes to my quizzes and my tests, they're all going to be timed. And if you're not, using these little tips and things or practicing them while you're doing your work, then you never know, when you're making mistakes without those things. So please, when you're doing these types of problems, don't use your calculator. All right, you guys? So just start making it a habit so you get used to solving things without it. Oops, I should have went ahead and plotted that point. So we got -1, -3. And you'll probably think of me as like giving you guys, going off on tangent topics, but I'm ultimately just trying to prepare you guys for your future math classes, okay? Make you just an overall better math student. All right, let's do C here. C is the point at the origin. If you remember, I went over the definition of origin earlier, and that is the point 0, 0, right? Right here. And we're going to go ahead and transform that one into our new image by still plugging it into the exact same equations up here. So I have 0 minus 4 and 0 minus 3. I'm going to go ahead and simplify that, and I'm going to get -4 and -3. So let's plot it. 1, 2, 3, 4, 1, 2, 3. And that's C prime. I'm going to go ahead and connect these. These are congruent triangles because, as you can see, the lines are exactly the same length. If I look at AC and A prime, C prime, I could count and they're the exact same length. The angle measures are the same as well. So that would be your solution. Okay, now it's your turn.